Hello guys, welcome back to the channel. So today is going to be our last video of this particular playlist, which is called as Statistics for Data Science. So in this video, we are going to discuss about F-test. So basically this F-test is used to compare the variances of two data sets. So basically this F-test is useful to us to find the relationship, or else we can say to find the comparison between two data sets. So firstly, we have a formula for F-test called as F is equal to sigma of data 1 square by sigma of data 2 whole square, which is nothing but variance 1 by variance 2. So after doing this type of calculation, we will get a value for F value, which is maybe the value of this one. Let's think that that is going to be X, for example. So after finding this value, we have to calculate the degree of freedom for both the data sets. So that formula is going to be n minus 1 for this data set, and for this data set also it is going to be n minus 1. That means for both the data set 1 and data set 2, the degree of freedom is going to be n minus 1. But also we may get a value of alpha in the question itself. So after calculating the F value using the formula variance of dataset 1 by variance of dataset 2, we will get a value. So using this value and using both the degrees of freedoms, what we will have to do is we actually have to calculate the value of critical value using F-test table. So after calculating the critical value using F-test table, we have to compare both the F value and critical value. So based on that, we can make any assumptions. So for this, first of all, I'm going to draw a graph and I will show you how this will actually works. So I'm going to draw a graph here, and after drawing a graph, so I will draw my distribution. So for example, let us take a question that so there may be, we can consider that there may be two classes, namely class A and B. Let us think that the size of class A is 20 and class B is also 20. And also consider that we are given with variance of both these classes. So this 20 is actually my size and this is going to be my class name. So let us think that we got the variance as maybe 2.5 and 1.8, but also consider that in the question itself they had given our alpha value as 0.05, which is nothing but significance. So in order to use this significance, we can consider that 95% data is here, which is in the acceptance area, and our significance value is 0.05, which is our rejection area. So this is all is going to be my rejection area, as it occupies 95% of the area. This is going to be 5%. That's why for one, if we consider all this area as 1, we will get this as 0.05. So now we have significance value, that is 0.05, but also we have two variances. Now if I want to know the degree of freedom, I have to use this formula n minus 1. Here both the n's are nothing but 20, so that means n minus 1 is going to be 19. So we may have something like this. After all the calculations, degree of freedom 1 is equal to 19, degree of freedom 2 is equal to 19, and then significance value is 0.05. So if you know how to check the F table in the Google and check, or else if you don't know how to check it, so after getting all these values, if we check the values, or if you check the F table in Google by just typing F table PDF, you will get a PDF, and in that PDF for the position of alpha at 0.05 and degree of freedom 1 as 19 and degree of freedom as 2 as 19. So after finding the value of critical value in F table, we may get the critical value for alpha is equal to 0.05 and degree of freedom 119 and 219. So we will get degree of freedom as 2.20. So here I can plot 2.20. So now I have to calculate this F value, that means variance of 1 by variance of 2. If it is really greater than 2.20, I can say that there is a significant difference between both the data sets which were given, but it is, if the F value lies somewhere in this 95% of area, we can say that there is no significant difference between class A and B. So now to calculate the F table, to calculate the F value, I have to use the formula variance of 1 by variance of 2, which is going to be 2.5 by 1.8, as I have taken the variance values as 2.5 and 1.8 here. So if you do the calculation, we will get variance as, so if you do this calculation, we will get it as 1.39. So that means after calculating the value from Z table, we got 2.20, but now after calculating the F value using the formula, we get something like 1.39. So that means 1.39 is really less than 2.20. So by conclusion, we can say that there is no significant difference between class A and class B. So this is the conclusion we can write after finding the values of both critical value and F value and comparing it in a graph. So this is all about today, and with this video, this is the end of the playlist in which we are creating about statistics for data science. So we have done with one thing, and from the next video onwards, I'm going to show you the practical implementation of data science programs, and I'm going to show you how to create end-to-end machine learning projects using data science and using Python language. So if you don't want to miss those videos also, I would highly recommend you to subscribe to my channel and like this video also, because if you like the video, you may get recommendations of my next videos on your field. So this is all about today, and let us meet with a fresh content from the next video onwards with a new playlist on data science to implement the real world problems. That means to get dived into the coding part. So thank you.